Hi everyone, I am Whitroy. Today we will learn about voltage drop calculation. This lesson is broken down into 5 sessions. Session 1, Introduction. Session 2, Detailed Steps. Session 3, Examples. Session 4, Exercise questions and mock exam. Session 6, Summary. Session 1, Introduction. Voltage drop occurs when electrical energy is supplied to a load, resulting in a voltage decrease along the supply cable due to the resistance of the cable. It is essential to keep the voltage drop within permissible limits to ensure the proper operation of electrical equipment. For example, if a pump is installed 30 meters away from the power supply point and the voltage drops to 210 volts, the pump is not safe to power on as the supply voltage is far below its rated voltage of 230 volts. Voltage drop calculation ensures that the cables we use in electrical installations are sized correctly to handle the current demand and maintain the voltage drop along the cable within acceptable limits. The calculation involves 2 main parts. Part 1, cable size calculation. Determine the size of the cable based on the load current demand. Part 2, voltage drop calculation. Check that the cable size chosen meets the voltage drop requirements. By performing voltage drop calculations, we ensure that our electrical installations meet the requirements of the electrical equipment's rated current and rated voltage. In simple terms, when the electrical equipment or circuit is connected to the power supply, even over long distances, the cable chosen by voltage drop calculation will still provide the necessary voltage and current for safe and efficient operation. To do voltage drop calculation, we need to use the voltage drop formula. Be aware this formula is not provided in the EWRB exam, but it is in AS/NZS 3000 Appendix C4. That means you need to memorize where it is and the different formula forms, such as the formula used for single-phase installation. You also need to know how to transpose it. There are a few basic formulas used in calculation, and I will show them in the detailed step session. For 3-phase systems, calculate the actual voltage drop by multiplying the cable voltage drop factor, VC, by the root length of the circuit in meters, L, and the circuit current demand in amperes I load, then dividing by 1000. For single-phase systems, calculate the actual voltage drop similarly, but also include a factor of 1.155 in the numerator. Be aware that for single-phase systems, the cable voltage drop factor, VC, is the 3-phase cable voltage drop factor multiplied by 1.155. VD is the actual cable voltage drop in volts. L is the root length of the circuit in meters. I load is the circuit current demand in amperes. VC is the cable voltage drop factor per ampere meter measured in millivolts per ampere meter. To do voltage drop calculations, we also need to use 6 tables. These tables will be provided in the regulation EWRB exam. All these tables are from AS/NZS 3008, 2010. You can either get those tables from Standard 3008 or Google EWRB old exam papers used before 2018. If you are a New Zealand electrical apprentice, you should get a free copy of many electrical standards through the EWRB website. There are 6 essential tables for voltage drop calculation. Table 10, current carrying capacities for 2 core sheath cables, provides the current carrying capacities for different sizes and types of 2 core sheath cables, including those with thermoplastic insulation. Table 13, current carrying capacities for 3 core and 4 core cables, lists the current carrying capacities for various sizes and types of 3 core and 4 core cables with thermoplastic insulation. Table 27.1, rating factors for air and concrete slab ambient temperatures, offers rating factors to adjust current carrying capacities based on different ambient temperatures for cables installed in air or heated concrete slabs. Table 27.2, rating factors for soil ambient temperatures, provides rating factors to adjust current carrying capacities for cables buried directly in the ground or in underground wiring enclosures. Table 42, 3-phase voltage drop factor, VC, at 50 Hz for copper conductors, gives the voltage drop per ampere per meter for different sizes of multi-core cables with circular copper conductors at various conductor temperatures. Table 45, 3-phase voltage drop factor, VC, at 50 Hz for aluminium conductors, lists the voltage drop per ampere per meter for various sizes of multi-core cables with circular aluminium conductors at different conductor temperatures. These tables are crucial for accurate voltage drop calculations and ensuring compliance with electrical standards. Session 2, Detailed Steps. Part 1. Cable size calculation. Determine the size of the cable based on the load current demand. Step 1. Calculate total load current I load. For single-phase systems, the load current is calculated using the formula load current equals power divided by the product of voltage and the power factor. For three-phase systems, the load current is calculated using the formula load current equals power divided by the product of the square root of 3, voltage, and the power factor. If the power factor is not provided, assume it to be 1. Step 2. Adjust for future load growth. To adjust for future load growth, incorporate a percentage of extra current capacity. The formula to calculate the total load current with growth allowance is total load current equals the original load current plus the original load current times the growth percentage divided by 100. For example, for a 20% growth allowance, the total load current equals the original load current plus the original load current times 0.2, or simply the original load current times 1.2. Step 3. Select the minimum cable size based on the current demand. Select the minimum cable size based on the installation method such as buried, direct touching, or spaced, and the current demand. Use the appropriate tables, Table 10 for single-phase installations and Table 13 for three-phase installations. Ensure that the current carrying capacity of the cable is greater than or equal to the load current. Remember, the greater than or equal to means the current carrying capacity must be at least as large as the load current. Consider and apply the value of the D rating factor for the ambient temperature if it is not 30 degrees Celsius or for the soil temperature if it is not 15 degrees Celsius. Use Table 27.1 for ambient temperatures and Table 27.2 for soil temperatures. Calculate the maximum current carrying capacity using the D rating factor. This is done by multiplying the current carrying capacity of the cable by the value of the D rating factor from Table 27.1 or Table 27.2. Perform a final check to ensure that the maximum current carrying capacity is greater than or equal to the load current. If the cable size is sufficient, continue to the voltage drop calculation. If not, repeat the cable selection steps by choosing one size bigger cable. Part 2. Voltage drop calculation. Step 4. Calculate maximum permitted voltage drop. To calculate the maximum permitted voltage drop, use the supply voltage and the maximum voltage drop limit, which is given as a percentage. For example, if you have a 1.5% voltage drop limit in a 400 volt system, the maximum permitted voltage drop is calculated by multiplying 400 volts by 0.015. This results in a maximum permitted voltage drop of 6 volts. Step 5. Calculate maximum permitted cable volt drop factor, VC max. For a three-phase system, calculate the maximum permitted cable volt drop factor by dividing the maximum permitted voltage drop by the product of the length of the cable run and the total load current, and then multiplying by 1000. For a single-phase system, calculate the maximum permitted cable volt drop factor similarly, but also include a factor of 1.155 in the denominator. Step 6. Choose cable size based on voltage drop requirement. Use Table 42 for copper or Table 45 for aluminium to choose the cable size so that its volt drop factor VC is less than the maximum permitted volt drop factor VC max to meet the voltage drop requirement. This cable size must also meet the current carrying requirement determined in Part 1. This means the cable size must be equal to or greater than the cable size calculated in Part 1. If the chosen cable size doesn't meet both the current carrying and voltage drop requirements, then choose one size bigger until both requirements are satisfied. Step 7. Verify actual voltage drop. Ensure the actual voltage drop of the installation with the chosen cable meets the requirements. The actual voltage drop, VD, should be less than or equal to the maximum permitted voltage drop, VD max. There is an alternative method to perform Part 2, voltage drop calculation. It's important to master both methods. Now, I will explain the second method, which uses a trial method to get the correct cable size. From Part 1, we have the calculated cable size that meets the current demand requirement. Now we use this cable size to verify the actual voltage drop. The actual voltage drop should be less than or equal to the maximum permitted voltage drop. First, calculate the actual voltage drop. Using the formula for calculating cable volt drop, for three-phase systems, calculate the actual voltage drop by multiplying the cable volt drop factor by the route length of the circuit in meters and the circuit current demand in amperes, then dividing by 1000. For single-phase systems, calculate the actual voltage drop similarly but also include a factor of 1.155 in the numerator. Then adjust the cable size if necessary. Ensure the calculated actual voltage drop is less than or equal to the maximum permitted voltage drop. If the actual voltage drop exceeds the permitted limit, choose the next larger cable size and repeat the verification. By mastering this alternative method, you can ensure that your electrical installations are both safe and efficient. Okay, let's start session 3, examples. First, we look at the three-phase installation question. You can pause this screen for longer if you need to do the calculation yourself. After 3 seconds, I will show you the answer with all the steps. Ready? Here's the detailed solution for the answer to question 1. Three-phase installation. Review these steps and make sure you understand each part of the calculation. This will help you confidently choose the right cable size for similar installations in the future. Next, I will demonstrate a single-phase installation using the alternative method for the voltage drop calculation part. Let's move to the next question now. Okay, let's look at the single-phase installation question. You can pause this screen for longer if you need to do the calculation yourself. After 3 seconds, I will show you the answer with all the steps. Ready? Here's the detailed solution for the answer to question 2. Single-phase installation. Review these steps and make sure you understand each part of the calculation. This will help you confidently choose the right cable size for similar installations in the future. Now we move on to session 4, mock exam. Through examples, you will find that doing voltage drop calculations involves many steps. But generally, for the EWRB regulation exam, one concept equals 1 mark. So do we really need to know all the steps? The answer is clear, yes. Examiners can use any one step from all the steps to make a 1-mark question. So you need to know all the steps? I will use the previous example to create a few sample questions using multiple choice type questions. Here is the list of 7 questions. In question 2.1 and 2.2, it brings in the term about the adjusted VC for single phase. It means the 3-phase cable VC from table 42 times 1.155 to get the adjusted VC for single-phase cable VC. For more online mock exams, please contact your local polytechnic to access Moodle if you are a New Zealand electrical apprentice. As I have shared all my Moodle online questions with all New Zealand polytechnics exclusively, today we have completed the voltage drop calculation. There are lots of steps, and yes, it is hard. It usually takes students 2 or 3 days to get familiar with these steps through my training. By the way, the wiring rules, AS NZS 3000-2007, give a simplified method for calculating cable voltage drop. Appendix C, paragraph C4 on page 376, but it may actually appear more confusing. I will make another video when I am free. But keep in mind, you are required to master this method as it is within the boundary of the regulation exam. 2025, good luck!